Hi class, this is course 3, lesson 66, special right triangles. Hold on to your hats, you're in for a treat today. We have two types of special right triangles we're going to talk about. One is when you take half of a square, and the other is when you take half of an equilateral triangle. So given that we have half of a square, we know the angle measures of this triangle. This angle is 90 degrees because it's the corner of a square, and that angle has to be 90 degrees. We also know that the side lengths are the same on those two legs of the triangle because it's a square, so we know that those side lengths are the same. What that means then is that we have an isosceles triangle, so our base angles have to be the same. So we would take 180 degrees and subtract the 90 degrees that we know from it, and then we have to split that 90 evenly, and that gives us 45 degrees. So these two angle measures are 45 and 45 degrees. So this type of triangle is often called a 45, 45, 90. Okay? In the half of an equilateral triangle, we know that this angle here is 60 degrees because in the equilateral triangle, all three angles measure the same amount. So it's 60, 60, 60. So we know that that's 60 degrees. We also know that this is 90 degrees because we're talking about a right triangle, so we need a right angle somewhere. So that makes this angle at the top the smallest angle. 90 plus 60 is 150, so 180 degrees minus 150 leaves us with 30 degrees for this angle here. Okay. This triangle is often called a 30, 60, 90 triangle. So you'll need to know when you have a 45, 45, 90 and a 30, 60, 90 triangle because we know things about them. Okay. We know their side lengths. Okay, so I'm just going to fill in what I know about this one already. I know that's a 90 degree angle. This triangle is my 45, 45, 90 because it was half of the square. Okay. While I'm labeling the angle measures, I'm just going to go ahead and do that here as well. Now notice this one's flipped the other direction. It's okay, it still works the same. 90 degree angle. The larger of the two angles is the 60 degrees, and the other is the 30 degrees. Okay, so the hypotenuse is the equilateral triangle side. The 90 degree angle, the shorter side has the 60 degree angle with it because the shorter side has to be opposite the smallest angle. Okay, so let's talk about side lengths. This was a square, so I know that it's an isosceles triangle, which means this side, if this one is 1, then this side is 1 as well. So then what's that make the hypotenuse? Well, I take 1 squared plus 1 squared. The leg squared plus the leg squared equals the hypotenuse squared. Pythagorean theorem. So 1 plus 1 is 2 equals c squared. And then I would square root both sides, leaving me with the square root of 2 equals c. So this side length is the square root of 2. Okay, that's what you need to know. Your side lengths are identical here, and then it's the square root of 2. So it's 1, 1, square root of 2. Okay, so remember we called this triangle the 45, 45, 90. And so our side lengths are in the ratio of 1, 1, square root of 2. We don't do a decimal approximation here. This is exactly the length, the square root of 2. We want to know that in a 45, 45, 90 triangle, we have side lengths of, in the ratio of 1, 1, square root of 2. That will help us calculate some other side lengths here in a little bit. In the 30, 60, 90 triangle, we have to think just a little bit. Remember that this was half of an equilateral triangle? And so this side, the hypotenuse, is one of the sides of the equilateral triangle. And this side down here, the one side, the side with the 90 degree to the 60 degree angle, the short side, that was half of that equilateral triangle. So this side is half as big as the hypotenuse, which makes our hypotenuse 2. So now we can work through the Pythagorean theorem again. Leg squared plus the other leg squared equals the hypotenuse squared. So this is 1 plus b squared equals 4. We'll subtract 1, which gives us b squared has to equal 3. And if we square root both sides, we get b equals 3. Remember that the square and a square root offset each other. They are inverse. So square root of 3. Sorry, I forgot that. b equals the square root of 3. So this side length is the square root of 3. And remember that this was a 30, 60, 90 triangle, which then is in the ratio of 1, square root of 3, and 2. Okay, so they're telling you the sides that correspond to those angles, the sides that are opposite those angles are in that ratio. So 30, 60, 90, the side opposite the 30 is a 1, the side opposite the 60 is the square root of 3, and the side opposite the 90 is a 2. So in a 45, 45, 90 triangle, you have a square root of 2, and in a 30, 60, 90 triangle, you have a square root of 3. These are facts and new information that you must memorize. Okay, so let's do a few problems together. The shortest side of a 30, 60, 90 triangle is 5 inches. What are the lengths of the other sides? Okay, so what I would do is that I would sketch one and label things, okay? This would be the 60 degree angle because it's opposite the longer of the two legs, and this would be the 30. And I know that the shortest side, which would be opposite the 30 degree angle, is 5 inches. Okay, so now I have to think back to my ratios. This was 1, square root of 3, and 2. So the side opposite the 90 degree angle is twice as long as the shortest side. So this would be 10 inches. This side opposite the 60 degree angle, the other leg, is in a ratio of 1 and then square root of 3. So everything is 5 times as big, right? We have a scale factor of 5, so I need to multiply everything times 5 to get this 5 and this 10. Well, when you take 5 times a square root, it looks like this. That's it. It's 5 square roots of 3, or 5 times the square root of 3. That is exactly how long that side is. That's it. Okay? And I'm sure at this point you're going, I don't even really understand. That's okay. This is new, completely new information. We just have to work through a number of problems until we get it 100% in our heads, okay? So let's take a look at this example. A traffic sign in the shape of an equilateral triangle has sides 12 inches long. What is the area of the front of the sign? Okay, so equilateral means all the sides are the same length, and they tell us that they're 12 inches. So I'm going to mark this on here. We need the area, and remember the area of a triangle is 1/2 times base times height. And I can get a a height here by drawing this perpendicular so that I have a right triangle. And we just walked through this. This is half of an equilateral triangle. So I know my base of the triangle would be 12, but what's the height? Well, if I consider, and I'm going to switch to red, that this half here is 6, because it's equally 6 and then 12, and it's another 30, 60, 90 triangle. So I take the side opposite the 30-degree angle, the short side, and multiply that with the square root of 3. So my height is 6 square roots of 3. So I'm going to substitute all of this information into my formula. So I have 1/2 times, what's the base? The base is the whole length, it's 12, times 6 square roots of 3. Okay, so how does this work? Well, 1/2 of 12 is 6, and when you multiply with the square root, we only multiply the coefficient, let's call it, the number outside. We don't do anything with the square root. So 6 times 6 is 36, and we still have square roots of 3, and it was inches, and we were doing area, so it's 36 square roots of 3 inches squared. If we wanted the exact length, we would plug square root of 3 into our calculator and then multiply it times 36, which is what we'll do here in just a minute. However, here are two facts that you need to kind of memorize. Square root of 2 is approximately equal to 1.41, and the square root of 3 is approximately equal to 1.73. And we'll use those values to find actual estimations. Okay, so this is the last problem I have for you today. Here we have a baseball diamond. It's a square, and our sides are 90 feet long. So if a base runner tries to steal second base, so he's going to run from first to second, and the catcher throws the ball from home plate to second base, how far does he throw the ball? So we want to know this length right here. Okay? We want to know how far that is. Okay, so I took a square and I divided this into two 45, 45, 90 triangles. Since these were the same length, I know that these are 45-degree angles. So I know I have a 45, 45, 90 triangle. And remember, that is in the ratio of 1, 1, square root of 2. Okay, so the length here is, if my one side is 90, right, one of my sides is 90, so then my scale factor, forgot to say, scale factor is times 90. So I need to multiply this times 90, that times 90, and the square root of 2 times 90. Well, 90 square roots of 2 feet is exactly how far it is. Okay, but I'm talking an actual distance. And so if you were to tell me, oh, to throw from home to second base is 90 square roots of 2 feet long, I'd look at you like you were nuts. That's exactly what it is, but that doesn't mean anything to me. However, if I substitute 1.41 as the decimal approximation of square root of 2, I can multiply that times 90 and get a decimal approximation. 9, 36, carry the 3, 12 with 2 decimal places. So this is approximately equal to 126.9 feet. That makes more sense, right? If you tell me it's almost 127 feet, I know how far that is. Okay, so that's it today. It's a lot of information that might seem complicated, but it's very useful information to know that we have 45, 45, 90 triangles, and we have ratios of 1 to 1 to square root of 2 for side lengths, and we have 30, 60, 90 triangles with ratios of 1, square root of 3, and 2. And remember that these are special right triangles. Okay? I'm sure we'll have to help each other out a little bit in class, and that's okay. Brand new concept. Don't be afraid of it. With that, I will see you in class.